Welcome to the next video in a series of GIS tutorials geared towards local officials on how to use FEMA base level engineering datasets in GIS to support flood hazard mitigation decisions. This tutorial series was developed by the Water Institute of the Gulf in partnership with FEMA Region 6 through FEMA's Cooperating Technical Partners program. This video will discuss the ways in which planners may use base level engineering datasets to make decisions about future development. After importing and symbolizing data from the BLE tool, it may be helpful to download and import parcel data for the study area. This is likely accessible through the municipality's GIS department. A planner would need this data to understand risk at an individual parcel level. This level of detail will allow planners to make informed decisions about future development with more precision and present more conclusive justification for those decisions to stakeholders involved in local development. Again, it may also be helpful to use a world imagery base map or a world imagery hybrid base map. This allows for better spatial understanding for local stakeholders when presenting them with BLE data. In this next part of the video, we will walk through the discrete steps a planner can take in ArcGIS Pro to view and interpret flood depth data at the individual parcel level. The first thing that you'll want to do after importing local parcel data is to open the geoprocessing pane. In the search bar, type Zonal Statistics as table. You'll want to make sure that you're selecting the Spatial Analyst tool and not the Image Analyst tool. Before making the selection, right-click the tool and select Batch. Ensure that your parameters match the ones on the screen and click Next. After that, you'll select a batch input raster. The one in this demonstration is named Subdivision Parcels. You'll want the zone field to populate with the field linked to the parcel geometry. The one in this demonstration is called Assessment Number. The input value raster should contain the floodwater depth data that you would have symbolized and renamed in earlier segments of this tutorial series. For this demonstration, we will use the floodwater depth for the 1% flood event. Depending on your needs, you may choose to use this data or the depth data for the 0.2% flood event. Make sure that Ignore No Data in Calculations is checked. And for the purpose of this demonstration, under Statistics type, we'll select Minimum, Maximum, and Mean from the dropdown. You may choose alternate statistics based on your individual needs. Then hit Run. Once the table is complete, scroll down to the bottom of your table of contents and open the Zonal Statistics table. Here you'll be able to see the minimum, maximum, and mean values associated with floodwater depth at the parcel level. If you'd like to rename fields, simply click this button in the top right corner of the table and select Fields View. Double-click the field name in the alias column and rename to your liking. Once you've renamed your fields, right-click the subdivision parcel layer in your table of contents and navigate to Join and Relates, and then select Add Join. The input table should include subdivision parcels. The input join field should say Assessment Number, or whichever field is associated with the parcel geometry. And the join table field should contain the Assessment Number field. Click OK. Once the join is complete, right-click the subdivision parcels layer in the table of contents and navigate to Symbology. In the Primary Symbology dropdown, select Unclassed Colors. For the purposes of this tutorial, we will use the mean values as the selected field. For normalization, we will select Shape Area. For color scheme, choose one that works for you. In this demonstration, we'll use voxel sequential for the contrast it provides. Finally, we'll rename the upper and lower labels to reflect what they represent. We'll rename the upper label Higher Relative Flood Hazard by Total Area. and we'll rename the lower label lower relative flood hazard by total area. As you can see, there is a much higher relative flood hazard in the lower part of this subdivision. Save your project and continue to view and interpret your local data as needed.